Alright, in this video, let's look at second order linear differential equation. So we have two types. We have the homogeneous and we have the non-homogeneous. So homogeneous linear differential equation is an equation which is equals to 0. For example, let's say we are asked to solve for the homogeneous. Let's say we are asked to solve let's say we have an example. We are asked to solve let's say solve y double prime negative 5 y prime positive 6 y is equals to 0. Since it's equals to 0, it tells us that it is homogeneous linear differential equation. So let's see how we can solve. Let's see how we can solve this. So to solve this, we'll say this is solution. So we have our equation y prime prime negative 5y prime plus 6y is equals to 0. So next we can say let y is equals to exponential rx, like this. Let y equals to exponential rx. So we can say y prime, if we differentiate y, we should be having r exponential rx, like this. So if we differentiate y prime, we should be having r squared exponential rx, like this. So if you differentiate y here, you'll be having exponential r. Sorry, if you this the let y is equals to this rather. Then if you differentiate y, we're having this. That means this one multiply by this. Then differentiate this, you should be having this here. So we can now substitute y is equals to exponential rx, y prime is equals to r exponential rx, and y, sorry, yes, is double prime, that's the second derivative of y. This is equals to r squared exponential rx into this equation, into the equation. So what I'm going to do next is to um this is the equation y prime prime negative 5y prime plus 6y is equals to 0, like this is equals to 0. So our y double prime is equals to this. So this is r squared exponential rx negative 5. So my y prime is equals to this. So this is r exponential rx plus 6. Now my 6, my y is equals to this 6y. So we have exponential rx is equals to 0. So the next question you have to ask yourself is what's common in this equation. You can see, look closely, you notice that exponential rx is common among all. So you factor out exponential rx. So say exponential rx is common into this is r squared negative 5r positive 6 is equals to 0. See, if you multiply this by this, you have this by this, you have this, and this by this, you have this. So factor out this out. So next, we can say divide. If we divide divide both side by this, which is exponential rx, whereby exponential rx can cancel this. Then 0 divided by exponential rx, definitely 0. this is r squared negative 5r plus 6 is equals to 0. So next, let's factorize. We can factorize it. We have 6r squared here. Then multiply this. Then this will have 6r squared here. Sorry, let me just make it. Alright, we have 6r squared here. I have 6r squared here. So here we have negative 5r. We have negative 5r. Now we have to ask ourselves two factors whereby if I multiply, I will have the product of this, and when I add those same two factors, I should be having a negative 5. So what are those two factors? If I think, you notice that a negative 2r multiplied by negative 3r should give me a positive 6r squared. Then this, I'll have a negative 2r plus plus that's okay minus negative 3r should give me negative 5r, right? So the two factors are 2 and 3. So we can come back to this equation to say this is r squared, this is r squared negative 5r plus 6 is equal to 0. So since this is equals to 5r here, so you can say r squared negative 2r negative 3r plus 6 is equals to 0. So negative 2r and negative this should still give you negative 5r. So next, this is r squared negative 2r in bracket into this is negative 3r plus 6 in bracket also is equals to 0. So next, we can factor out. Next, we can factor out what's common into this bracket. What's common? This is r into bracket of this is r negative 2. So factor out what's common here. What are we going to get there? This is negative 3 is common into what? R negative 2. Now notice that these two brackets are the same. This is equal to 0. Notice that these two brackets are the same. Now you can just pick one of the bracket. This is r negative 2 like this, and r negative 3 is equals to 0. So therefore my r1 is equals to 2 and my r2 is equals to 0 like this. Oh, we are not done with our equation. We are not done with solving the second order homogeneous differential equation. So what are we going to do next? Now you can say from the formula, which is y is equals to c1 exponential r1 x plus c2 exponential rx. So yeah, so we now substitute the value of this r into this equation. So you can say this is y is equals to c1 exponential r is what? 2x plus c2, sorry, plus c2 exponential r2 is what? 3x, and this is my final answer. Thank you guys for watching. Don't forget to like, share, and subscribe. Thank you.